Hi everybody and welcome back. Now it's time to evaluate our data set to test its functionality and catch possible bugs. Before doing so, we import at first emgorg.augmenters as IAA. Next, let's import matplotlib.pyplot as PLT, and finally matplotlib.patches to draw the rectangle. At first, we create our augmentation pipeline by using IAA.sequential. We can use this class just like we use compose from Torch Vision. You simply pass a list of augmentations. At first, we can use IAA.gamma contrast to change the brightness or contrast of the X-ray image. Next, we use IAA.affine with random scaling by a factor between 0.8 and 1.2, random rotations from -10 to 10 degrees, and random translations from -10 to 10 pixels. Alright, our augmentation pipeline is defined. Next, we set the path to the label CSV file, the train subjects, and the train route to finally create our cardiac data set, to which we pass the labels path, the patient's path, the train route, and our augmentation pipeline. We can now obtain an X-ray image and corresponding bounding box by simply passing an index to our data set. Let's use simply 0. To check that the bounding box is correct, let's create a 1x1 plt.subplot where we at first visualize our X-ray image. As usual, we have to get rid of the channel dimension so matplotlib can plot it. Let's use the bone color map. After that, we can define the bounding box by using patches.rectangle, to which we pass at first the coordinates of the top left corner, followed by width and height. Due to the fact that we stored x and y max instead of width and height, we need to compute those values again. To get the width, we simply subtract bbox 0 from bbox 2. In contrast, to get the height, we use bbox 3 minus bbox 1. Second to that, we define the edge color to be red and face color to be none to prevent matplotlib from filling the rectangle. Now we are ready to add this rectangle to our graph by using axis.add_patch, to which we pass our rectangle. Alright, let's have a look at the result. Perfect! We can see that the bounding box still perfectly matches the heart, besides the image being rotated and scaled. Let's have another try. Same result. And again, perfectly matches the heart. Awesome! Looks like we got a working data set. Now we can move to training our cardiac detection network. In order to use this data set in the training notebook, we can create a separate file called dataset.py as an example, to which we simply copy our necessary imports and the cardiac dataset class. Please don't forget to save. This allows to import cardiac dataset from dataset. Otherwise, you can also continue your workflow in the dataset notebook. One final note before we end this lecture. You can freely decide whether you want to predict the top left and bottom right corner of the bounding box, or the top left corner as an example, plus width and height. It's just a matter of preferences. In the next lecture, we are going to train our cardiac detection network. Thanks!